Hello everyone. As you all know, we have introduced a new and exciting predictive analytics module in Minitab. It includes cart, random forest, and tree-net. In this video, I will show how you can take advantage of cart and why it is so important that you are aware of all of the benefits that you can get from this exciting engine. What I have here is the data set. So we'll start with the regression analysis, and we are trying to predict the price of diamonds based on the 4 C's: carat, cut, color, and clarity. So if you look at this data set, and it has about 50,000 different records, if you build a conventional regression model, what you will discover is that it gives you a test performance of around 92%. But what is interesting about a model like this, the actual equation is shown here, and as you can see, there's all the traditional coefficients and all the other things. Now let me turn around and show what happens if I build a cart tree. What I have here is on the screen is the results of a cart tree analysis, and notice by default it actually developed a pretty large and elaborate tree with 234 terminal nodes, but the test performance is now 97%, way better than the conventional regression. Now, why is this happening? Cart has a built-in ability to accommodate interactions and all these other things that may or may not be present in your data set, and in this case, that particular aspect of it produced a much better performing model. Now, if this 234 node tree is too much for you to look at, and I must admit, the tree itself can get very elaborate, cart actually offers you a possibility to look at smaller trees. In this case, I basically identified a 6-node alternative cart regression tree. And as you can see, initially we are predicting the average price of a diamond around 4,000. However, what cart automatically determined for you, if you take all of the gems with the carat weight below 0.995, price drops to 1,630. Otherwise, for larger gems, it goes up to 8,000. And then likewise, if you continue studying this tree further down, at some point, clarity comes in, and then you will see interaction of all these different variables as the tree develops. If you allow this process to go all the way down with all of the validation and everything, as you saw, we jumped from 92 to 90% accuracy on our regression problem. And as we looked also at the structure of the problem and the solution, a regression equation is something that you would have to understand on the individual type of coefficient level, whereas when you look at the cart tree, you can actually identify all the right pieces in place for you. So cart will give you a very different story that is a lot more intuitive and easier to understand and present to others. So keep that in mind. Sometimes running a simple regression tree can give you an enormous advantage in terms of seeing an alternative side to the story and getting a much better understanding and a structural understanding of what's going on with your data set. In addition to that, you will often identify a number of serious problems that may have creeped into your data set, because we live in the world when sometimes problems do occur. You have fraudulent records, you have faulty records, you have all sorts of outliers and missing values, and cart will be able to identify those for you at ease. Now, what I've showed right now is a regression problem, but cart is equally powerful in treating a classification problem, or specifically binary classification problem, or even multinomial classification. Let me show you an example of a binary classification problem here. What I have is a data set that deals with records of marketing. It's marketing at a financial institution, and some people responded yes, some people responded no to some kind of phone offer to subscribe to new services, for example. So it's a very classical, typical business application that you might consider here. Now notice here is what's so interesting about this data set. We have a whole mixture of different variables here. You have age, job category, education. Some are continuous, some are categorical, some are nominal, some are binary, etc., etc. And we want to build a model that helps us to predict the responders based on all of these other alternative inputs. Now, first of all, let me show what happens if you build a conventional binary logistic regression in this case. And again, let me open up the results here. Notice that the classical linear, the logistic regression gives us about 74-75% area under ROC curve, which is a pretty good result. Now, the problem though is that when you look at the actual equation, it shows you this lengthy set of numbers and all of these individual dummy variables and all the other things that are really difficult to wrap your heads around. And then let's just look at the coefficients and all these other things. There's a lot of numbers here and a lot of explaining to do, especially for someone who doesn't really understand logistic regression. And we're getting about 74-75% accuracy in terms of area under ROC curve. Here is an example of that same data set that I ran in CART, and as you can see, I'm getting 14 node CART tree, which is pretty straightforward and easy to understand. Here is the history of CART runs, and when you look at the tree itself, again, notice we've started having about 12% responders to our marketing offer, and then CART automatically identified that depending on what contact month that particular conversation took place, for some parts of the year the response rate went up to 26%, for others it dropped down to 9%, and similarly if you continue descending down, you'll see that someone who has a mortgage actually has a lower response rate, and someone that doesn't have a mortgage had a larger response rate, and so on and so forth. So this is how it works, and as you can see, all of these runs, they are can be very helpful and give you a very different example compared to say the binary logistic regression that I showed in this case, that requires a special expertise and special understanding in terms of how to run it. Now, going back to CART, in addition to seeing the tree itself with this type of natural structure that is easy to understand and easy to present and easy to talk about, the tree itself, if you look at the performance, in this particular case is on par and even slightly better than the conventional logistic regression that we've seen before. Now, furthermore, the tree also ranks all of the input variables according to their contributions to your model. So this way you can actually identify how different parts go and what are the variables of interest to focus on. So to summarize, when you run CART, it's not like you're replacing either a conventional regression or logistic regression. You're actually adding a very different technique that has a whole different set of features and capabilities. It automatically handles interactions, it automatically handles nonlinearities, and most importantly, it shows you solution in the form of a segmentation, which is a lot easier to understand and a lot easier to communicate. And in some cases, depending on what's going on in your data set, you might even get higher accuracy. Now, does CART give you the best accuracy ever? By all means not, because it's just the starting point of modern machine learning that is basically a class of data-driven algorithms. There are many ways to improve above and beyond CART's accuracy, and I will talk about it in some other videos dedicated to random forest and TreeNet. But even by itself, CART gives you this amazing a new power, and the insights that you'll get from it can be quite spectacular. So why don't you go ahead, try it, and use it on your data and see how far it can lead you. Thank you. Well, Hello everyone, today I would like to talk about random forest. As you all know, we have introduced new predictive analytics module in Minitab, and the random forest is one of the power tools that you can add into your predictive analytics toolset. What is random forest? Well, the random forest is basically, it's centered around building large number of independent individual either regression or classification trees using bootstrap aggregation. Now, why do we need random forest? The main important part here is that the random forest allows you to dramatically improve overall performance of your predictive models. Okay, so let me show what it means. I have a data set here that gathers information about the energy output in megawatts of a solar power plant. And you have a time of day here in the military scale. You have sun elevation in degrees, sun direction, temperature, precipitation, cloud cover, humidity, wind speed, wind direction, and barometric pressure. So what we want to predict here, we want to predict the energy output of the power plant based on all of these geographic and weather characteristics. Now, why is that important? Well, as you know, a power plant usually is a part of a power grid, and depending on the conditions that we are forecasting for tomorrow, we are going to have different output, and therefore, depending on the demands of the grid, it's very important to understand exactly what kind of power output we are to expect, right? Because then we could take certain different measures to deal with it. So the more accurate the prediction is going to be, the more is the business success of this particular problem and its solution. So let me show you the histogram of the energy here. As you can see, it varies because the data collects hourly power output for the entire year. And if I were to build a conventional regression analysis, notice my overall equation would be presented here. So there's a lot of different coefficients to look at because I'm looking at the mixture of continuous and some nominal variables. And if I were to look at the overall performance, I'm getting about 70% R squared on the test sample. In other words, there is still 22% of power output fluctuation that I cannot capture, cannot predict using this particular regression model, doing it a conventional multiple linear regression way. Well, let me switch to random forest here and show you what that exact same setup would give me if I were to run random forest. Well, in this case, what you will see is that random forest off the bat gives me 87% accuracy on the test sample. That's a whopping 12-13 points increase, right? So it's a much better performance than I had before. Well, let me have a look for the regression. We were getting 78%, and now we're getting 87%, right? So it's a 9 points improvement performance-wise compared to what I get with the classical conventional multiple linear regression. And in addition to that, random forest also ranked all of the variables according to their contribution. So now I know that if I look at the sun elevation, that is the most important driver. Well, it kind of makes sense when we work with solar power plants, right? But when you look at all these others, you can also see that cloud cover is the next important one, humidity is the next important one, and interestingly enough, wind direction and wind speed ended up being towards the bottom of the list here. So now, as you can see, very quickly I managed to build a regression model that is drastically outperforming conventional regression, and it gives me additional pieces of information that I can look at and I can study. So this is what you can expect more often than not when you run random forest in a regression setting. Now, random forest is powerful enough to handle not only regression but also binary and multinomial classification. Let me show you an example of binary classification. There is a data set here that deals with bank marketing, And in the bank marketing, there's a collection of records where we have observed who responded and who did not respond to a certain bank offer to subscribe to some kind of business product. And we also gathered up for each contact information about that particular person, the contact type, whether they have a business loan and other things, etc., etc. So again, our main objective here is try to predict a specific business outcome in the binary classification setting. Now, if I were to build a binary logistic regression, let me show it here. So binary logistic regression would give me area under ROC curve, which is what is normally used as a performance criterion in this class of applications, is about 74 and a half, right? 0.745. And if you were to look at the actual equation, you would get this convoluted collection of numbers, etc., etc., etc. So it's not easy to understand, right? Because you would have to look at a lot of numbers, a lot of coefficients, a lot of these different things. Not the most intuitive way to understand what's going on. Now, you could build a cart model to get a better structure that I showed in another video, or if you're interested in the ultimate accuracy, you can go ahead and try to build a random forest model. And here's what happens when you build a random forest model. Again, off the bat, when you look at the area under ROC curve, it jumped to almost 77%. Now we go from 74.5 to 77. Well, in this case, it's not as dramatic as in that energy example, but it's still quite substantial. And in many business applications, if you can squeeze out extra percentage point out of your ROC performance, could mean a lot of money saved or a lot of additional profit and revenue to be made. So this is the kind of scenario that we have in classification. And again, notice random forest showed you relative variable importance, so all of these things are now ranked. And as you can see, contact month turns out to be the most important driver that separates different responders and a different response rate, followed by how many days have been since previous contact, followed by the age of the person, and followed by contact type and some other characteristics of the account. So as you can see, regardless whether you have regression or classification problem, random forest has all of these capabilities to produce a much better performing models for you, which depending on the application will be exactly what you're looking for. And it also gives you some additional insights into the structure. Now, what you do not get from random forest, you do not get a more detailed description of how the predictions are made. Okay, so for that, in the case of classical regression, you would have to look at the actual equations. Or if you were to run a single cart tree, whether it's regression or classification, the tree itself would show you a set of rules that lead to different outcomes. In the random forest, you have a large collection of a large number of independently grown trees, and the power of that collection comes as an ensemble. So you will not be able to understand the intricacies of internal connections, but you will gain additional benefit of getting superior accuracy. And finally, if you want to get both, if you want both accuracy and some additional insights into the internals and the dependencies, for that you would have to go to stochastic gradient boosting, which I will discuss in a different video. So take it, use it, enjoy it, and see what kind of insights and what kind of accuracy you can achieve on your own data using these modern predictive analytics data-driven tools.